Burendo AI, the journey towards agentic AI. I can't remember what it was on the Leeds Digital Fest description, but this is what it became. You will notice this talk is written 100% by a person. No AI was harmed in the making of the talk, so there's no emojis at any point. There also is probably going to be more spelling mistakes, but we'll move on to that. So I'm Luke Towell. I'm a senior engineering consultant here at Burendo. The prerequisites for the talk, so there are no fire drills planned. The toilets that I've been informed I need to tell everyone are, if you go out of the main door and turn left, then the toilets are along that corridor, if you haven't found them already. If there is a fire drill, at 6 o'clock, the main door closes, so if you need to make your way out before everyone leaves, please use the rear door, which is the door immediately to the left of the lift. The fridge is at the back of the room. Please get up whenever you want. Go help yourself. There is also pizza. This talk is not going to include anything groundbreaking. It's not cutting edge. There will be no crazy things that you have to buy memberships for and they ramp up the price at the drop of a hat. None of that will happen. And the aim is for it to be AI without the hype. So hopefully you should be able to leave the talk with an idea of how you can implement this yourselves if you would like to. So, if you have been to any talks this week, you might have already seen some glossary pages. This glossary is just terms that we are going to cover today that are going to pop up in the talk. So the term agent is an AI system that can perform tasks, make decisions, and interact with its environment to achieve specific goals. So the example that I'm going to talk about is an AI assistant that processes bid documents and generates its own responses depending on what you have provided it. An embedding is a numerical representation of text or data that is converted into vectors that captures semantic meaning, which allows the AI models to understand and process the content mathematically. So it's not text like you and I would communicate. It's a mathematical, a numeric representation of that text. An example here being man there has been numerically broken down into its various different attributes, and that is displayed in a list. Apologies if you can't see at the back. A vector. So a vector is a multi-dimensional numerical array that represents data points in mathematical space, which allows for LLMs or artificial intelligence models to understand and process that content mathematically. So if you think of an LLM that breaks down the word cat and lion in that mathematical space, cat and lion would be located in a similar location because they share similar attributes. Whereas if we were to provide the words cat and apple, they would be in very different locations if you were to visualize that space. A foundational model. So a foundational model is a large-scale pre-trained AI model. So like the likes of Claude or GPT or Titan, they serve as a base for building specialized applications and can be fine-tuned for specific tasks. So multiple AI tools use LLMs as their foundational model. If you've used Cursor, that is by default built on Claude. LangChain. So LangChain is a framework that simplifies creating applications with large language models by providing tools and libraries for chaining operations, memory management, and agent creation. We are going to go more in depth with regards to what we use LangChain for, but LangChain assists in chaining together processes that include foundational models. So for example, we use Claude and we've used LangChain to chain together an awful lot of its context. So why are we here? So Burendo Labs within Burendo is a bit of a program of work where you are able to essentially pick up something that you are interested in, a project that you're interested in, or put forward some form of project. And hopefully you have worked on it previously, and provided that you've put the effort in and the bid is deemed to deliver some form of value, you are able to go and pick it up and work on it and potentially have some time off client to investigate if it has legs. So the Burendo lab that I picked up was building an agentic AI bid response assistant. So what was the problem? So let me ask, how many people in the room regularly fill in sort of tenders to work or bids? Yeah, 2, 3, 4, 5, 6. Yeah, so a couple of us might be familiar, but are they normally easy to understand when you immediately pick them up? No. So bid specs, often lengthy, complex, written in language that makes them difficult to understand. You want to produce a good one, right? Like in order to get the work, you need to produce a good bid. But they take significant time and effort, and normally you have a pretty tight deadline. So our question was, how can we streamline this process, improving the structure, quality, relevant to the response, crucially, whilst also keeping Burendo's tone, our human judgment at the heart of it. So the human needs to be involved. They need to be kept in the loop. And hopefully we avoid sounding like a soulless sort of AI-generated text. It should help us to stand out for the right reasons, not just because we've responded to the bid quickly. So the ask was design and build an AI system to support bid response creation, demonstrate agent collaboration, memory, and tool use, and include a way for humans to intervene, review, and improve AI outputs, and hopefully compare different agentic AI frameworks. So yesterday, actually, my least technical friend was asking me, what am I doing my talk about? Because I was talking about the fact that I am presenting, and I thought actually that's a pretty good response. So to sum it up, essentially, to win government work / work for government agencies, they usually put out work to tender, and that response is called a bid. So I've made an AI agent that I'm going to walk you through, and the use case is that you provide it with the bid spec or the bid questions, and then it creates the summary of those questions in easier to understand English. It also pulls out the key concepts and key points that the user should be targeting. Using the context that it has about Burendo and about the bid that we have provided, it is then able to generate specific answers for that bid, and then produce final answers that the user can hopefully critique and edit in order to get to a finely tuned bid response. So this was the solution that we came up with. Sorry, excuse me. Are there any questions at the moment about what we're doing or why we're doing it? No? Excellent. So the proposed solution. So this is what we came up with that we were going to implement. So the blue boxes are inputs that we are going to provide to the AI. The purple boxes are where the AI is performing a task or it is processing information and it is going to produce something. And then the yellow boxes are the output that we get from the AI that is provided to the user. And the user is, as we've already discussed, kept in the loop and able to provide feedback. So when we moved on from that, we came up with this architecture. So the idea was we would create a Python application, just a quick proof of concept, create a Python application that would make use of LangChain and Boto 3 in order to interact with AWS services. The AWS services that we were going to use are Amazon Bedrock, Amazon DynamoDB, some models that are available on Amazon Bedrock. The ones that we are going to use are Anthropic Claude and AWS Titan text embeddings. And then we're going to use Bedrock Knowledge Base, which makes use of OpenSearch Serverless, which essentially contains all of our all of the vectorized Burendo handbook. So that's that handbook there. And all of that is going to come together to give us some form of AI capability. Any questions about our proposed solution? Yes?
So Sorry, did you mention that you're saving the embeddings in Dynamo?
So no, so we save our conversational history in Dynamo, but all of the embeddings are actually stored in OpenSearch serverless at the moment. Thank you. I missed a bit. We also make use of a local vector database, which is I think it's called FAISS or FACE, which is provided by Meta. So we make use of a local version of that in the initial proof of concept. Yeah.
I was going to ask as well, with the embeddings, is there a specific, I know in Python, if you want to embed, you use sentence transformers, a specific model. Is there a specific model that you chose?
Yeah, so as part of the use of Bedrock, I'm going to go on to this in a minute, but we've chosen to use AWS Titan's text embeddings, which essentially is able to take text chunks and then you're able to provide it with the parameters that you want it to produce embeddings of. And then once you have produced the embeddings, it creates the vectors and you store those embeddings in a local vector database. That's how we do it here. We do change that, and I'm going to go on to how we change that in a later version, if that's all right.
Yeah, sure.
Cool. Anything else? Yeah.
So Anthropic Claude.
Yes.
I know they're more sensitive about data.
Yeah.
And not to store it or use it to improve their models. Are there other models that have the same sort of, like you can use them and not worry that it's going to leak out, or the information's going to leak out, or?
Yeah, so I'm going to talk about that. I'm not going to answer that right now, if that's all right.
Yeah, okay.
And we'll talk about that in a minute. At the back?
You mentioned the Burendo handbook. What's
Yeah.
that?
So the Burendo handbook is a assortment of markdown files that detail sort of our policies and the way that we like to work and the way that we approach work and hopefully the standards that we adhere to when we work with clients. In that S3 bucket, we have put essentially a copy of our Burendo handbook, all of the markdown files, into that S3 bucket. And then using Bedrock knowledge bases, you're able to synchronize the OpenSearch serverless database to contain a vectorized version of all of those markdown files. Stephen.
I was just going to say, if you want to see our handbook, it's on handbook.burendo.com. So feel free to have a look.
There you go. Cheers, Stephen. Okay, so to the crux of it, what is an AI agent? So we defined it earlier, but an AI agent is an artificial intelligence agent. It's a software program that can interact with its environment, collect data, and use data to perform self-determined tasks to meet predetermined goals set by humans. An AI agent independently chooses the best actions it needs to perform in order to achieve those goals. And that's taken from Amazon Web Services. And you can see from the diagram there, the user puts in a request to the agent then has access to files if they've been provided, a cloud network potentially. You can see I've detailed Amazon OpenSearch service. It can reach out to another agent or another LLM if it wishes. And finally, it normally has access to tools or other data sources in order to be able to decide what job it wants to do. So, Amazon Bedrock. It's not just where the Flintstones live, which is quite a niche joke, and I'm sure it's very, very age appropriate, but oh well. So, through the use of Amazon Bedrock, you are able to access multiple foundational models from multiple providers using one AWS service. So just to name some of the providers, you can use Anthropic, you can use Cohere, you can use Meta, you can very recently, I think, September 25th was the last update. You can use some of the OpenAI GPT models. And also Amazon have their own, unsurprisingly, they have their own LLMs that you can use called Titan typically. And they're all available via one single API service, one single AWS service, which is Bedrock. There are multiple features within Bedrock to enhance your AI capabilities. So you can use guardrails, which keeps your agent on track. I'm going to go a little bit more into guardrails and what it does with regards to security later on. You can also use flows, as we've already discussed, knowledge bases, and there is also Bedrock agents as well if you would like to build on top of that. Wrapped, and all of the Amazon Bedrock comes wrapped in the security, privacy, and safety of AWS. So why did we choose Amazon Bedrock if it isn't apparent from all of that information? So we are an AWS partner, so it was a service that we already have access to. We are familiar with it, and it is deemed to be enterprise ready. You can use it safely and securely. There is no monthly subscription that we have to pay for. So does anyone currently have an OpenAI, an Anthropic, a Claude membership? Subscribe to Cursor. So it's like £20 for each one, right, at a time. With AWS, you don't need any of them memberships. You just go through Bedrock. Obviously, you need the AWS membership and to be signed up via AWS, but you don't need anything else. And it gives you access to all of the models available via Bedrock. We wanted to understand the process end to end. We wanted to know exactly what was happening with our data, with data that we put into it. Where does it go? Who uses it? Who has access to it? And the use of Bedrock means that we are able to do that because we have implemented the application completely. It's private. The data stays within our AWS account. It isn't used for training. It doesn't leave AWS. It isn't even sent to the third-party supplier of the model. So Anthropic don't have access to it when we use Claude. OpenAI wouldn't have access to it if we used GPT, one of the GPT models. There is actually, and I sent it to Paul earlier, a really good paragraph on the AWS documentation which outlines the account controls that the AWS models team have access to. And they are locked down to be able to upload models, upload the training data that is provided by the model provider, and then they are able to train the model. They are not able to interact with anybody else who is using the model, and they don't have access to any of the prompts that are provided to the model either. So with regards to your question of how secure is it, it's AWS level secure, like nobody, supposedly according to AWS, has access to anything that you put into it. And then the final sort of benefit of using Amazon Bedrock was the fact that it gives us the potential to easily try out and use multiple foundational models. In this example, we only use Claude and AWS Titan embeddings. The other day, I was playing around with what awful images can I generate of myself using the Titan image LLM. And there's also multiple different video, image, text models that are available. So we've chosen Bedrock. The next priority for us is securing our our AI capabilities. So as I've sort of lingered on, the benefit of Bedrock is that, yep, it comes with the AWS shared responsibility model. So AWS ensure that all of the security around their infrastructure is their responsibility. Our responsibility is the application. So we make sure that that is completely secure, and that's kind of at Burendo our bread and butter, which is great. Bedrock guardrails. So I quickly sort of mentioned it before. It keeps the agent on topic of filtering out both information that you potentially don't want the model to have access to. For example, personally identifiable information. If somebody could potentially put that in, you will keep that out of the agent's hands, but also potentially information that you don't want your model to be giving back to users. So, for example, earlier whilst I was getting ready for the demo, I started asking, can you give me advice about investments? To which the model came back and said, no, that's not my job. And then I rephrased the question and thought, well, I'll ask it directly. I'm going to ask about investing in Apple. Can you tell me if that's a good idea? It probably would have said, no, at the moment, they aren't doing anything with AI. But it didn't. It just said, that's not my job. Then, finally, the thing that is completely within our hands is the data that we input into the model. So all of the data that we provide the model to and all of the context that we give the model access to has been proofread and quality checked by us, because garbage in, garbage out. We want to make sure that we are not providing the model with any information we don't want it to have. Are there any questions so far about what I'm talking about? No? Excellent. So I've mentioned it a couple of times. Context. An LLM is ultimately just a conversation machine, just a one-shot machine, if you do not provide it with any context. You can say hello to it, you can tell it your name, you can give it a load of information, but if it doesn't remember all of that information, it's useless. So in order for us to implement something with memory, we've made use of DynamoDB, and that keeps all of the conversational history and our user configuration for context. Then, as we've discussed, we've made use of Bedrock knowledge bases, which provide the wider context to the LLM about who is Burendo and what is it that we do. And that is available to the LLM all the time. So the agent has access to that content via the knowledge base all the time. What we've then introduced is a vector DB storage using FAISS, or FAISS, which is for the session. So each session that a user spins up will generate a new object within FAISS, or a new session identity within FAISS, and all of the vectors that are provided as part of that session are uploaded into that, which means that on a session-by-session basis, you don't get any overflow of information. It's all available. It's only available for that session. And coming back to your point earlier, how do we handle vector storage and embeddings? So at the moment, if you upload a document via the API, it will first be sent to Amazon Titan embeddings, which will chunk up that model and turn it into vectors, which kind of look like them. And then they are stored for the first iteration on a local database, on a local vector database. For the second iteration, which I'm going to go on to, they are stored in PG Vector, which is cloud hosted on RDS, but I will touch on that later. So the next point, creating the flow. So this is the solution that we came up with that we've already sort of ironed out. We provide bid materials. They are passed into the first job, which is a bid material simplifier. At that point, the agent will produce a summary of the question to be answered, including key themes. The user is then able to review that summary and decide if they're happy with it or they're not. If they are happy with it, then they can they can inform the agent that they're happy with it and move on to the answer outline generator. The agent will use the context that it already has with regards to the bid materials, the summary of questions to be answered, and it will generate an answer outline. At that point, if the user is happy, they can move on. If they're not, that answer outline can be tweaked and they can add more context and hopefully get a better answer. Once they are happy, it will then move on to the answer writer, which will produce a more prose-based version of the answer. So at this point, we're talking sort of tables, bullet points. At this point, we're talking actual prose that could potentially be used in a bid response. At every point, we've deliberately made sure that the user is still kept in the loop. If we had wanted to, we could have scrapped all of the user input, and we could have just said, here's the bid materials, I want an answer, and the agent would have been able to do bid material simplifier, then answer outline generator, then answer writer, and just giving you the answer at the end. But because we wanted to make sure that the answers were as fine-tuned as possible, we've broken it down into those steps. So how did we create the flow? As I've just said, we could have just had multiple agents that handle each stage, and we switch between each agent, and then at the output, they merge it all together to produce a final answer. We could have had a single agent that handles each flow based on the user input. We could have just made use of multiple system prompts and switched between those system prompts. Or if you have looked at Bedrock step functions, if you've looked at Bedrock flows, one of the things that they talk about is that you can actually just use step functions to invoke your agent, and it will do it based on the conditional flow of a step function. I think that's a bit janky, if I'm honest, but I think there's better ways to do it. But that was an option. Ultimately, our main question was, how do we ensure that the user is involved in the process? And we came up with this way, where we have a single agent that does each step, but we actually provide multiple system prompts depending on what step we're at to the agent. Any questions so far? Yes?
So it's the last stage was refine answers on it.
Yes.
Is that the final output, and what is that, just like a block of text, or is it a document, or?
So at that point, it would just be a block of text for the proof of concept. It would be great if we could stick it all in a markdown file and output it. But no, at the moment, it's just a block of text that it produces. Yep.
So is this in like a chat interface, and that's how you're giving feedback to the LLM?
I'm gonna demo that. No. That's 100% the question you should be asking. Right. So. Oh, sorry. Excuse me.
Do your bid materials ever exceed the context window, and if they do, how do you manage that?
So that's a really good question. They did exceed the context window when we were just copying and pasting the bid materials in. We would quite easily reach the context window of, say, the 200,000 tokens or whatever. The way that we managed it was instead of providing the bid materials into the conversational history of the LLM, if you chunk it all up and you store it in a vector database,
Use RAG to pull out what you needed.
essentially, yeah. But instead of storing it, you can store it in a vector DB, and then you can store as much as you want, as long as the database has capacity. Which on AWS is pretty much limitless. You just have to pay for it. So architecture recap. So we've got a user, we've got a Python application. It has a local vector DB. It uses LangChain. Via Boto Free, it then talks to Amazon Bedrock, which then has access to Bedrock knowledge bases, Amazon DynamoDB, and AWS Titan text embeddings. And the foundational model that we make use of is Anthropic Claude, all of it which sits inside of AWS. So now I'm actually going to give a bit of a demo and explain how it works. So the first iteration of the application was a command line interface app. So super simple. It was all knocked up in a week. And the idea was, essentially, can we start up an initial conversation? Can we have different stages? Can we provide files so that it's vectorized? And can we store it in a local DB? So this is what we came up with. This is the initial CLI application. Everything is made better with ASCII art. If you don't think so, you're wrong. And the initial conversation starts very simply. Choose one of the following options. I either have a bid that I'm already working on, so I have previous context saved that I could potentially use. I'm starting a fresh bid. Tell me more about bid AI. The main options that people tend to choose is going to be 1 or going to be 2. Here, I've started a completely fresh bid. So I've started a new bid. And at this point, you can see that the stage that I'm at is I'm a question summary. And at this point, I uploaded a file. So you can see here, I've stated, please can you process the following file? And then I've provided a file path. I'm aware that it's not the best user interface and it's not the best for a presentation. We will go on to talk about that. At that point, it's processed the file. It tells you each of the stages that it goes through. So you can see that the document's loaded, how many characters has it got in it, the fact that the document is being split, all of the chunks that have been produced. So it's produced 11 chunks, and then it's successfully added 1 of 1 files. At that point, we then move on to actually interacting with the agent. So we say to it, excuse me. So we ask it, please can you process that file, produce me a summary of all of its context. So here, it told me the ingested materials, and then it produces a question summary of the context within the file. Obviously, in the CLI, it's not that readable. But at the end, it always asks, are you satisfied with this summary? In this example, I say, yes, I am satisfied with that summary, and it will move on to, I'd now like you to use the information that you know about Burendo to generate an answer outline for question AQB1. You'll be surprised to hear that the giant sort of OpenAI and Anthropic and Meta do not train their information knowing about who Burendo are, which is, to me, shocking. So we've had to provide that context. So here I am explicitly saying, I need you to go and use context that we have provided for you. And at that point, the agent has gone away, and you can see that using LangChain, it has been able to combine the context sources. So saying there that it's used a merge retriever, it's able to create an answer outline. So it talks about Burendo's consultancy approach, and it talks about our core values and the alignment with regards to service design, because that's what the question has asked it of. It gives us a question summary detailing all of our output. Then at the end, once it's outlined the key points that we want to include in our answer, provided that the user is happy with the outline, we move on to the next stage. So we say yes at this point, and then we will go on to this next stage, which is me saying, based on the previous outline, I'd now like you to generate an answer that can be submitted. It goes away, it uses the vector stores again, it uses the combined merge retriever, it prints out our problem statement, and then it prints out a solution outline, which I know that it's hard to see here, but hopefully you can see that it is actually more prose than we were seeing previously with regards to bullet points. And then finally, I believe it ends with a friendly, in summary, Burendo's capability to deliver service design consultancy services is characterized by our comprehensive approach, user-centered design principles, industry expertise, and our commitment to client success, which to me sounds like good sales. So that was the first pass. That was our proof of concept. And as no doubt you've just seen, that is janky. If you give that to someone, especially someone who isn't technical, they're going to say, what is this? Why is it written in green screen? And how do I use it?
Very frankly, I was unimpressed.
Yes, there you go. In short, so what we've learned so far is ensuring that the agent has the correct context is imperative. We need to give it that context. It needs to be able to know who we are, what the previous conversations are that it's had, and what files it's been provided. We've learned the functionality of LangChain, Bedrock, and knowledge bases. We've secured user input using guardrails, so I'm going to go on to that in a minute. And we've also confirmed that everything looks better with ASCII art. But where did we go next? So next, we went to this solution architecture diagram. As you can see, we've scrapped our Python application. That wasn't doing the job. Instead, we've moved to a Vite application, which is hosted in S3 is stored in S3 and hosted via Amazon CloudFront. That then reaches out to a fast API application. So we created a load of API endpoints that can be used, and they are all hosted via Amazon ECS. Via the fast API application, we are then able to call Amazon Bedrock. We're able to call AWS Titan text embeddings. The embeddings have now changed. So to your earlier question of where do we store that, all of the contextual session memory is now persisted to RDS. So we make use of PG vector, which is in RDS. So one of the problems that we had with the CLI application was the fact that as soon as you killed that CLI application, you lost all of your contextual memory. We no longer have that issue because it's all persisted in RDS. All of our conversational memory is still stored within DynamoDB, and we still make use of the Bedrock knowledge base. And our foundational model is still Anthropic Claude, sat within AWS. Any questions about that current architecture? Yes?
What is a Vite application?
So a Vite application, Vite is a JavaScript framework which is built on top of React. Anything else? No? Excellent. So the next stage. So I'm hoping you think, oh, that looks a bit better than a CLI. So our next stage was this application here. So as you can see, it is fully browser accessible. So this is what we now use to talk to the agent, which hopefully looks a bit better than a CLI, and you can see what's going on. The first things first, at the moment, when you first spin it up, you have no active session. Then you are able to provide, you're able to create a session. And then you can provide files via the UI. That will then send that off to the back end, and you can see that the files are processed successfully. What you don't see is all of the stuff about it saying, I'm chunking the file, I've got X amount of chunks, I've written it to a vector DB. But you can see that it's been processed. You don't have to just provide one file, you can provide multiple if you wish. Just provided. At that point, you can then put in your prompt and say, go away and do this for me. So I'm going to avoid the us waiting for a response, but this is just an example of we've provided materials. It's then gone away and produced in plain English a output of those materials. So it says, yeah, you've given me a bid tracker and a bid spec. It's then able to provide a question summary for the question that we are targeting and the answer. And then it is able to provide a solution answer. And you can see that that is much more prose than the bullet pointed list of potential answers. So that's the agent that we have implemented thus far. And if we go back to here, are there any questions so far? No? Okay. So, the added functionalities and refinements to our initial sort of CLI application. We've introduced a Vite application. So, everything is now available in the browser. You can log in, you have persisted sessions. You can go to those persisted sessions and access all of your previous ones. We've created multiple API endpoints, which enables us to tie into the service using various different platforms. So if we want to use Slack, we can use Slack. If we want to use another form of integration or another form of messaging service, we can easily give people access to our endpoints. we've implemented a persistent storage mechanism for session-based embeddings, and unfortunately, we've killed our ASCII CLI, which now only lives on my computer. The progress that we've made for all of this is we've created an agent that is able to make use of Claude's LLMs via Amazon Bedrock. And it all, again, just to label the point, stays in Amazon Bedrock. Doesn't go anywhere else. We've utilized Bedrock knowledge bases and Bedrock guardrails. We've created an application that enables users to interact with the agent, create individual sessions, and make use of session-based context. We've implemented the ability for users to upload their own information and have that information be processed by the agent, and ensured that all data remains in our control. And we've made use of multiple models via Bedrock. So just whilst we were developing this, we've touched on Claude Sonnet 3.5, 3.7, and 4. Amazon haven't released a new version of text embeddings recently. If they had, we'd have probably tried that out as well. It would have been super convenient in Bedrock. But we've put in a load of effort into ensuring that we've built great systems, or a great system. But ultimately, as I mentioned before, garbage in and garbage out has never been sort of more important, as I'm sure you're all aware when dealing with agents. So even with the progress we've made, good prompts are still essential. So within the application, we've made use of user prompts, and we've made use of specific system prompts. So we have 4 system prompts, one for each stage of the flow. And each prompt contains an agent role and its expertise, the response requirements, so what should the response contain, the response format with regards to how do I expect it back. Do I expect it back as text? Do I expect it back as a list? Do I expect it back as a markdown table? We also provide examples, so providing examples of possible responses, and we provide specific guidelines, so reinforcement of criteria to make sure that it gets it right. I doubt I'm teaching people, I'm probably teaching people to suck eggs with regards to prompt engineering, but this is all stuff that we've genuinely made use of when we've developed the agent. Some of the issues that we had, so Bedrock implements its own token limits when sending prompts to foundational models. We ran into this a couple of times where if we had been using the Claude API directly, we would have been able to provide a larger amount of tokens, whereas I believe at the time Bedrock was implementing 75,000 tokens and Claude 3.5 was implementing 100,000 tokens. So that is just something to consider. I believe with Sonnet 4, they are on an even keel with regards to the amount of tokens that you can provide. As you increase the number of libraries and enhance functionality in your applications, it's very easy for the size of containers to grow to considerable sizes. Initially, we weren't hosting the application on ECS using Fargate. We attempted to host it in AWS Lambda. Because of the amount of functionality that is added within the LangChain libraries, it grew too big. So we had to host via ECR and ECS. Obviously, I'm sure we're all aware, data storage in the cloud can become expensive. Bedrock, by default, if you create a Bedrock knowledge base, will push you towards using OpenSearch serverless. OpenSearch serverless is quite expensive. So one of our to-dos is actually to find an alternative to that. And the big learning was the CLI was educational, but ultimately it just wasn't feasible for users. So with that in mind, what is coming in the future? So as I mentioned, LangChain is sizable. So I would like to do a comparison of LangChain versus non-LangChain. When I implemented LangChain, I did notice there was actually a sort of significant time increase between responses. So if you call the model directly, it is considerably faster than if you are using LangChain. I would like to do an investigation into other approaches or products, so using potentially Crew AI, specifically Bedrock agents. We do technically use a Bedrock agent for the use of knowledge bases and to reach out to various other contexts. However, I'm very interested in how it would work with multiple agents. The creation of additional functions and tools that the agent can access. So can we give it more tools to be able to do more things? User-controlled models, so the ability for a user to actually switch between their models would be quite nice in the UI. And then comparative metrics for real-world implementation versus the use of bid AI. So how long is it actually taking for people to write bids by hand compared to how long does it take for them to do it with bid AI, or how much does it cost is another metric I would be quite interested in, because at the moment this is all a concept, right? Kind of like the entirety of AI, and that ties us into cost analysis. Another thing, as I've already touched on, is I would quite like to look at a bit of a refactor with regards to how we are using our knowledge bases. So I've been Luke Towell, that is me, that is my LinkedIn, that is my GitHub if you are interested. Are there any questions? Yes?
Have you looked at the inflection point between costs where it makes more sense to host your own model on like an EC2 or something versus using Bedrock?
I have not.
Okay.
Yeah. That sounds quite interesting though.
Yeah.
What's the rationale for the shift between your agents and the workflows being through free text prompts?
The rationale was that I wanted to ensure that I kept the human in the loop.
Mm-hmm.
So I wanted to ensure that at every point it went back to somebody and said, are you happy with this? And if they said, yeah, then it would be able to move on. But if they didn't and they wanted to tweak it, or they wanted to, I don't know, say, oh, well, you've missed this bit because I'm aware that it's in the document, go back and do that. They had complete control over it. Cool. What I found was that if you attempted to just do it on sentiment, it would be like, oh yeah, they're happy, and move on to the next stage, whereas I wanted to completely remove that.
Cool, so that bit between the stages and the workflows intended to be conversational?
Yes. Yeah.
So you talked about chunking one of those documents.
Yes.
Do you have a specific chunking strategies, or did you just go with like a basic 500 with an overlay either side?
So I believe I went with 750 with an overlay either side, but I used the Titan text embedding model, and I provided the parameters that were sort of default. I wasn't happy with it, or I didn't think that it created good overlay, so I increased the overlay. That was pretty much the change that I made for my embeddings. Yes?
What alternatives are you considering to LangChain?
At the moment, I don't know. I'm considering writing... So this is something that annoys some engineers. I'm a massive nerd, so I really enjoy writing code. So I would like to write it myself and just write all of the interactions myself. So there is no LangChain, or there is no framework. However, time-wise, I'm probably going to end up looking at some form of alternative, but I don't know at the moment.
Have you tried tuning the model instead of using RAG?
No, it seemed like the fastest way to do it was RAG, and also the cheapest way to do it. From what I've read and what I've learned, tuning using something, you can tune in Bedrock, you can also tune in SageMaker. Using either of those is quite resource intense and expensive.
Makes sense.
As you've got it at the moment, have you got a sort of indicative cost for how much?
So at the moment, to run on a monthly basis, it's running at around £200 a month. The most expensive part of that is OpenSearch. So if you get rid of OpenSearch, you probably cut that down by about £75. Token-wise, so you do pay per token, per request with Bedrock. It is negligible. I think in the month, whilst I've been hammering it, I've spent less than £10.
So yeah, it looks fair.
Yeah. Neil?
How do you say your perspective on AI has changed from the start of this project to where you are today?
Healthily skeptical. So for those of you who don't have the context, I am not an AI adopter. Well, I am clearly, but I don't view it, or I didn't view it favorably. I would say that I can definitely see where it adds value now. It is still infuriating regularly with regards to some of the responses that you get out of it and some of the logic that it attempts to apply. But yeah, I would definitely say that I can see where it has use cases, and I'm very interested in taking it sort of forward and seeing where it can be applied elsewhere. Whereas,
Has doing this project convinced you that you get consistent answers out of it? Are you still concerned that even with all the guardrails and even all the structured prompting, is it consistent in its behaviour?
I would say that, do you get consistent answers out of it? No. It's still, it can still be pretty flaky. Earlier, whilst I was setting up the demo, I provided it with the same file on 3 different conversations, and I got 3 different answers back for a summary of that file.
What happens if you fiddle around with the temperature and turn that right down to the bottom?
So you can completely reduce the temperature. You can reduce its K probability as well, so that it, or specialize its probability so that it only takes from the top 4 instead of everything. And it gets a bit more accurate, but it's still not 100%. But I would say that they've definitely gotten better. So I started when 3.5 was sort of being phased out. So I used 3.5 for about 2 weeks, and then I went to 3.7, and that was better than 3.5. And 4 at the moment is very, very good, and you get better responses out of Sonnet 4, and they're more consistent. Guardrails, I would say, is very capable. I'm quite impressed by the fact that, like, as I said earlier, I can ask it many, many, many times about investments, and every time it will come back and be like, no, that's not what I do. Ask me about Scrum, and I'll be like, oh, okay, cool. But, so yeah.
Is there any capacity for it to, or would there be any capacity for it to look at what bids have been successful, and then look at that data and maybe use that to enhance its suggestions for the questions that it's answering?
There is a company that does that called PKI. They literally take all of your bids. Like, if you've got a history of with the same company, they'll take all of the previous ones, the ones that have been won, the ones that have been lost. But that's a lot of machine learning in the background.
Yeah, there is the capacity for it to be able to do that. At the moment, does it do that? No. But if I was able to provide that context, then yes, it will be able to.
The other thing I was going to ask you is, you said that you've got the Burendo handbook.
Yes.
And it gets, so obviously it's only going to provide a response to the information that you put in.
Mm-hmm.
So on an ongoing basis, how do you make sure that the information that you're putting in is up to date, and who's responsible for that in the organisation? Because I suppose that's quite a responsibility that you've got to make it in line with.
So,
do you know what I mean?
Yeah. So for this, the way it is at the moment, you can just update the files that are contained within that S3 bucket. What you could do in the future is have a job that just ran every day over the Burendo handbook that is published on a daily basis. Well, published when it's updated,
Yeah.
and that job would read all of those files and update the content
Yeah.
of the S3 bucket. But we don't have that at the moment. But that is probably how I would do it. And you could use, there's numerous Python libraries that are able to web scrape, and that would be fine. Yeah. Awesome. Thank you very much. I hope that was useful and gave a bit of insight into sort of the way my brain works and how I'm figuring out AI before it kills us all. That's a different book. I am doing another talk on Thursday of next week about my skepticism around AI. So please come to that. Yeah.